Sanibonani Bafundi, and welcome back to our second segment. Now, line graphs illustrate the relationship between two variables. In this case, the two variables are time and carbon dioxide concentrate. Make the graph large enough to accurate plotting of the points. The graph should have two axes, drawn neatly with a ruler. There is a vertical y-axis which has the dependent variable on it. In this case, the dependent variable is the carbon dioxide concentrate. The x-axis has the independent variable that you are controlling on it. In this case, the independent variable is time. You need to label these axes and write in the units which the variables are measured. You also need to subdivide the axes with graduations. This must be done according to a scale. The divisions between the marks must be equal. The subdivisions on the axes must be labeled. Now you're ready to plot the points on your graph. Plot all the points accurately. Then draw a smooth line joining the dots. Now do not extend the line beyond the points that have been plotted. This is called extrapolation. You only extrapolate beyond the known data when you are predicting something from the original trend or pattern of the graph. Finally, provide the graph with a heading that mentions both variables that are being compared. Sometimes you'll have to draw more than one line on the graph. This is called a multiple line graph. You may use color to distinguish the lines from each other, but then you must label these lines or provide a key. Now try out your new skills by drawing a line graph of the following. Nandi kept a record of her new baby's mass over the first 6 months. She recorded the information in a table. Now plot this information in a line graph. The independent variable goes on the x-axis, and in this case, it's age. The dependent variable will go on the y-axis. The axes need to be labeled and the units inserted. Now the axes need to be scaled and the subdivisions on the axes labeled too. Now you go to the table and you plot off the individual points. Use a smooth line to join the points. Now remember to insert a heading that reflects both variables. Have you done it? Well done. You have drawn a line graph. Now can you interpret the information from this graph? Nandi's baby became sick during the first 6 months. Can you tell from the graph how old the baby was when it became ill? Nandi's baby became ill at about 4 months because the line drops showing a decrease in mass. Has the baby recovered? Well, Nandi's baby recovered because the line shows an increase in mass, which probably means that the baby regained its health. Now, have you learned that data can be quantitative and qualitative? You draw a line graph to show the relationship between two variables of quantitative data. The axes have numerical data on them. However, when you draw a bar graph, the one variable is qualitative rather than quantitative. Or another way of plotting it, the independent variable is discrete. A discrete variable is always a whole of something. There can never be any in-between values or fractions on the axis. Discrete variables are not continuous. Now here's some examples to give you a better idea of what I'm talking about. Variables such as mass, time, rate, volume, density, these are all continuous data because they are quantitative. They are numerical. You have half kilograms or quarter kilograms. This is not the case with discrete data. Color is an example of discrete variable. Red, blue, green, purple are colors. These are discrete values. You cannot have purple and a half or red and 3/4. In terms of province names, you cannot have Gauteng and a half. Countries, names of animals, genetically inherited characteristics, these are all examples of discrete variables. We're going to go into a short break and I'll see you right after.